Welcome to Command Line. In the previous multi-thread introduction video, we learned what is a thread and what is the difference between a thread and a process. But we didn't discuss why we actually need a thread because we have seen the order of execution of different threads are going to create a confused state in the data part, right? But still, why we need that kind of confusion. So, in this video, we are going to learn why threads are important, how they are going to be useful, and we are going to see our first Python program using multi-thread. So let's go to our school days. Let's think about the algebraic equation. The very first equation we learned in the algebra is a plus b whole square, right? A plus b whole square is nothing but a square plus b square plus 2 times ab. So hope you remember, or else this is a formula, just memorize it right now. So the point here is to get the final answer, we actually need to calculate a square first, b square and 2ab, then we have to add all three. But when you actually see, there is no particular order in calculating a square or b square or 2ab. We can even calculate 2ab first and a square second and b square third, right? Or we can actually calculate them in parallel. So this is why we need multi-threading. In programming scenarios, in the real world execution scenarios, there are situations where we can do operations in parallel. So here, when you have a 8 CPU in the machine, why you are going to run these three instructions, a square, b square and 2ab in a single CPU. If you execute them, all the 7 remaining CPUs are going to be idle, and this one CPU is going to execute 3 instructions. It is going to take times to execute 3 instructions. But instead, if you put each instruction like a square to CPU 1, b square to CPU 2 and c square to CPU 3, then all three are going to take execute in parallel, and every CPU is going to take just the time of executing one instructions. So by the time, let's say it is taking 1 second to execute one instruction, instead of you waiting 3 seconds, you get all three answers in 1 second itself. So it is a 3 times improvement of the performance, right? That's why we are going for multi-threading. So using multi-threading, we can actually do some independent operations in parallel, and it is going to heavily increase our performance, and we are going to utilize the hardware much better. As I said, we have multiple CPUs in the machine. Don't run on a single CPU in a sequential way. Just use multiple CPUs as much as possible, so you are actually getting benefit of the money you have paid. So what are you going to do? Like, what is the program we are going to do here? Initially, we are going to have the main thread as usual. The main thread will be running on the CPU 0, and the main thread is going to take the input from the user, is going to take the value of A and value of B. These are going to execute in sequential. Once it got the value, first it is going to deploy a new thread to CPU 1, and this thread is going to calculate A square. After this, obviously we know main thread is going to continue. At this point, it is deploying another execution, another thread to CPU 2, which is going to calculate B square, and still continuing. At this point, it is deploying another thread which is going to calculate, sorry, it is going to run on CPU 3, and this is going to calculate 2ab. All three are 3 multiplications, and still the main thread will be keep on continuing. And at this point, the main thread wants to wait for all the 3 threads to complete their task. So 2ab will get completed, it will come here, and this will come here, then this will come here. Once all the 3 threads got their execution complete, the main thread is going to calculate a square plus b square plus 2ab. The final calculation will happen on the main thread itself, but the independent multiplication calculation will run on 3 different threads. So if we have run this on the main thread itself, it is going to take much longer, just because we have parallelized them into CPU 1, 2, 3. It is going to take lesser amount of time. So that is expectation here. Let's go for the implementation. Here is the implementation. I have already written the code. Let me walk you through this one. So actually, to use multi-threading in Python, we have to import the threading library. You can see, oh my god, the Vim mode is not actually good in Mac. So the threading library we have to import, and then we are importing sys library because we want to gather the input from the user. So user is going to pass us what is a and b as a command line arguments, and we are going to parse that using sys library. And random, I will come to this part in a moment, and we are going to calculate a plus b whole square. So if you notice, all the three parallel operations, right, a square, b square and 2 times ab, all three are multiplication operations. Only the argument is going to be different. For the first a square, the arguments are going to be a and a. For the second, the multiplication against b and b, the multiplicand and the multiplier are just both are b. And the third operation, the multiplicand and the multiplier are a and b, right? So that's what we are going to create a multiply function. This multiply function is going to take two arguments, the multiplicand and the multiplier. Additionally, it is going to take a third argument, which is nothing but a key. Why? Because if you notice clearly in multi-threading, just give me a moment. So if you notice clearly, the main thread actually deploys a new thread, but it is not waiting for the new thread to complete, right? So the main thread will deploy the multiply function, but the multiply function will not get a chance to complete before the main thread moves on. So how can the main thread get a return value from the multiply function? So in the threaded executions, there are no actual straightforward way like a sequence execution. So in the sequential programming, the main thread will be waiting for the function call to complete and return back the value back to the main thread. Like both are running on same thread. So the thread actually, the instruction goes to the function executes and completes until the last instruction. The last instruction will return a value back to the main function. The main function will receive it and use that for future use, right? But here in multi-threading, the main thread is not actually waiting for the threaded function to complete. So the threaded function, when it actually completes, may not have a chance to give back the results back to the main thread. So what we do is we actually keep all the data into the global variables itself. So we know, right, all the logic part, all the threads in a multi-threaded programming are going to share the data part. So you write into the data part, and that will be picked up by the main thread or some other thread later point of time. So that's why we are passing the third argument key here. So what we actually do is we have a global variable result. It is declared here at line number 18, and this global variable I am going to write inside it is a dictionary. So in the dictionary's key value, I'm going to write the product. So this multiply function is actually calculating the product of multiplicand and the multiplier, and it is storing the product result into the result global variable. It's a dictionary. Inside the dictionary, it is creating a key value. So the key is nothing but we are passing as an argument. So it will be a square or b square or 2ab. So that key will be populated by the multiply function. Additionally, the multiply function prints the data for our convenience, and the main thread is supposed to collect the data from the result at a later point in time. We will see that in a moment. So this is a multiply function. It is very simple. It is taking the multiplicand, the multiplier and the key. Then it is calculating the product. After calculating the product, it is storing the product into the global variable called result. Right. So now coming to the main function. The main function is the main thread here. So you can see it is actually checking whether there are 3 arguments. If there is less than 3 arguments, it is going to throw an error because we expect the user to pass both a and b as an input. And if there are 3 arguments, we parse them into integers. First variable is going to be a, and second value which is passed as b. And now we are creating 3 threads. So we call a square thread, and for that the syntax is threading library which imported at the top, threading.thread, and the target function, what function is going to be running on that particular thread. So thread means it is a logic unit, it is an execution unit. You need to give a set of instructions to be executed in the thread, and that execution unit, that instruction is the multiply function. So a thread will be created and deployed into another CPU, and in that CPU what instruction is going to run, that is passed as the argument target. So you say target equal to some function, that function will be put into the other CPU. So here we want the multiply function to run on that CPU1, and the multiply function is going to take 3 arguments, right? So all the three arguments are passed into a new argument. So this args argument is an argument for the thread function, and whatever value passed inside it will be passed as an argument to the target function. So this is syntax for creating a thread. So thread is a class inside the threading library, and this class constructor takes two parameters. There are other optional parameters. These two are important parameters. The first is a target function. The target function is actually having the instruction that is going to run on the other CPU and the arguments for the target function. If the target function is going to take no argument, we don't need to pass this. If the target is going to take, in our case, the multiply function is taking three arguments, so we are passing, for the first case, for a square, the multiplicand and the multiplier both are a, and the key is a square. And we are creating another thread, so b square, and the instruction which is going to run in b square also is multiply. So at this line, CPU 1 is running multiply with value a as arguments, and at this line CPU 2 is going to run multiply function. So you can see the same function, but it is getting executed in two different hardware. So here it is CPU 1 and here it is CPU 2, and the arguments are different. This time in CPU 2 we didn't pass a as argument, we are passing b as the multiplier and the multiplicand, and the key value is going to be b square. And third, after deploying these two threads, we are passing another thread. We are creating a new thread on CPU 3, and that CPU 3 is also going to execute the multiply function only. So same function getting executed three different places, and the arguments are 2ab. It should be 2ab, so let's pass 2 times ab. So the multiplicand is 2a and the multiplier is the b, and the key is ab product. So now these three lines actually created three different threads on three different CPUs, but they didn't actually start executing, and it is a programming construct, but actually to start the execution of the thread we need to call the start function. So these are the instance, these are the object of the thread class of Python threading library, and we have to call the start function of those objects to actually start executing those particular threads. So we are starting all three threads. Thread A getting started on CPU 1, thread B started on CPU 2, and thread 3 started on CPU 3. So all are started at the same time. So the main thread is not waiting for them to complete. So at the line number 34, the thread A is still running, it didn't complete. So it is not sequential execution. We are sequentially starting the thread, but we are not waiting for the thread to complete. So at line number 33, we are starting an execution in CPU 1 and immediately starting execution in CPU 2 and immediately starting execution in CPU 3. Now all CPU 1, 2, 3 are executing the multiply function in parallel, and the main thread is not at all waiting for them. So after starting all three, this is the place we are going to wait for each thread. At line number 37, we call the join function. You want to wait for a thread, you have to call the thread named as a join function. This is syntax. And at this point, the main thread is going to wait for the thread A, the CPU 0 or the CPU 1 to complete its multiply function. And at line number 38, we can be so sure that the first thread is completed its task. If the first thread is completed its task, then obviously we know that the result will have a square value. And then we are waiting for the B thread to complete. Then we are waiting for the third thread to complete. At line number 40, we can be so sure that all three threads we have created previously are completed. So it means we got the result in our result variable. So the result variable has a square and b square and ab product. So we have 2. So then it is not required here. I will remove this one. So I didn't think I have put like this. Okay, here 2 is coming into picture. This is a plus b whole square I am calculating in the main thread using the value a square calculated in thread 1 and the value b square calculated in thread 2 and the value ab product calculated in thread 3. So after storing that value, I am printing that in the output console. Let's execute this code and see what actually happens. 1 second, I'm not able to go into the console, so it is Mac clear. So I have to go into cd code. So this code is actually checked into GitHub. You can check in my GitHub profile and get the code. So you don't need to actually live copy the code. You can clone the repo and actually make some changes and execute and learn about the code. So here what we are doing multi-threading. Okay, we got the code. So Python simple multi-threaded, and we have to pass 10, 20 or 2 3 we'll pass 2 plus 3 whole square 25 should be right. It should be 25. So we got the answer 25. It is correct. And you can see that first multiplication a square 2 square runs first, and 3 square b square runs second, and ab runs third, and at the end we are doing the final calculation. So if we run it multiple times, we may need to see the order different, but actually if you see, the order always stays same, right? So multi-threading will be beneficial when you are having a bigger workload in your actual threading function. So here our multiply function runs only one instruction or hardly 3-4 instructions, and moment you deploy a thread, moment you start the thread, immediately it will go in completion mode. So before even you start the next thread, the first thread will complete it, because the first thread is very small. So we are not seeing much of difference here. And another problem in Python is we are using Python 3.12, I think. Yeah, it's Python 3.9. So from Python until Python 3.13, Python is not actually having a clear multi-threaded concept. Python is having a global lock. We will learn about that in a later point of time. But in Python, until Python 3.13, if you run any Python multi-threaded code, maybe that is running as a single thread. So you have to check that the environment, and you have to make sure it is really running a multi-threaded scope or not. So maybe that is also a problem here. We don't know that, but let's not worry about it. What we are going to do here is, let's try to add some load to our process. So I told you, right, if we introduce some load to the multiply function, that is actually the threading function, right? Maybe we'll add some simulated workload. So kind of create, okay, this function is going to take some more time. So in that case, if that function is going to take more time than the normal execution of 4 instruction, then there may be some delay, right? So I'm going to introduce a random delay here. So for that I'm invoking the random library. Then so I'm creating a randomized delay. So I'm creating a random number between 0.1 and 0.5. Then I make the multiply function wait, and this value is not going to be same. Every time you are going to invoke the multiply function, the wait time is going to be different. So different invocation is going to wait different time. So maybe the a square may take 0.2 seconds, and b square may take 0.5 seconds, and ab may take just 0.1 second. So as these three are running in parallel, based on the workload, their completion time will also be different. So let me save the code and run this one here. So if I execute it, you can see here the order is a square. It's not a square, it is 2 and 3. It is ab, and then b square, and then a square. Maybe because you can assume the load on the thread 1, the CPU 1 is more, and CPU 2 is moderate, and CPU 3 is very less. That's why the execution happened differently. If I run it again, the order may change. Yeah, this time you see a square happened first, b square happened second, and ab happened at the third. Maybe run one more time. This time again a square, ab, and then b square. So the order of execution is not determined. That is the advantage of multi-threading. So instead of you run 3 instructions sequentially on a single CPU, you can run those 3 instructions on 3 different CPU in parallel. So the execution time cuts into 1/3 of the total execution time. You are better utilizing hardware also. So this is the syntax. You need to import the Python threading library, and to create a thread you have to call threading.thread, and you have to pass the target function which is going to be executed in that thread, and the arguments for that particular thread function. So not for this function, it is for the target function which you are passing. What are the arguments it is supposed to get, you have to pass as arguments here. And moment you create these three threads, the thread is not going to be alive, the thread is not going to run. To actually run the thread, you have to call the start function for each corresponding thread you have created. So at this point in time, the thread will come into life. The A square thread will be running in a different CPU altogether. So here B square will be running on different CPU and AB product is running on altogether different CPU. And if at all you want some data back from those threads, you have to share the data via global variable. There is no other mean for the threads to return back a data to the main thread or any other thread. The threads can communicate only via the global data structures. So here we are having a result global data structure, and the thread function is going to write its data into the result data structure, and here we are going to use that particular data from the result variable to form the final value. And while creating the final value or while calculating the final value, we have to make sure all the three threads completed their execution. Otherwise, the value will not be there, right? So to make sure those threads are completed, we are making the main thread wait for those corresponding threads. So to wait for a particular thread, you have to say the thread name dot join. This is syntax for making a thread wait for another thread's completion. So this line number 40, at this place when the execution is at here at line number 40, we can be so sure that thread A, thread B and thread AB product are all three are completed. So if they complete, the data is available and we calculate the final value and we print the final value. Hope you understood the thread. So in this video we learned why multi-threading is important. Even though it is complex to understand, comprehend, to see, visualize a parallel processing, and it is going to create lot more new problems we are going to see in the further videos, but it is going to give a very big benefit of utilizing the hardware very well, and it is reducing the execution time substantially, right? So that's the reason we are taking the overhead to actually save the cost. Hope you find this video useful. Hope you learned the new syntax of Python, multi-threading, and the concept behind multi-threading. And if you like, please don't forget to give a thumbs up to this video, and please subscribe to this channel, because we are going to have a lot more exploratory videos. We are going to learn distributed systems, system design, and multiple other things using the basic simple concepts. And thank you for watching.